In class 11th, we have studied some special functions like identity function, constant function, polynomial function, modulus function, rational function, etc. along with their graphs. Now we will study about different type of functions based on their domain, codomain and range. Let us first revise the definition of the domain, the codomain, the range of the function. Function. If x and y be two non-empty sets, then a subset f of Cartesian product of x and y, written as, is called a function or mapping from x to y if and only if, first, for each x belonging to x, there exists y belong to y such that x comma y belong to f, and second, no two different ordered pair of f have the same first component. In other words, a function x to y is a rule which associates to each element x of x a unique element y of y. The unique element y belong to y is called image of the element x of x under the function f. It is denoted by fx, that is y equal to fx. The element y is also called the value of the function f at x. Now domain and range of a function. Let f be a function from x to y, then x is the domain of the function f, and range of f is equal to fx, such that for all x belonging to x, the set y is called the codomain. Now consider the function f1, f2, f3 and f4 in the given diagram. Here we observe that the images of distinct element of x1 under the function f are distinct, but the images of two distinct element 1 and 2 of x1 under f2 are same, namely b. Further, there are some elements like e and f in x2 which are not images of the any element of x1 under f1, while all elements of x3 are images of some elements of x1 under f3. The above observation lead to the following definitions. First definition, a function f from x to y is defined to be 1, 1 or injective if the image of distinct elements of x under f are distinct. That is, for every x1, x2 belonging to x, fx1 equal to fx2 implies x1 is equal to x2, otherwise f is called many 1. The function f1 and f4 in figure 1 and 4 are 1, 1, and the function f2 and f3 in figure 2nd and 3rd are many 1. Definition 2. A function f from x to y is said to be onto or surjective if every element of y is the image of some element of x under f. That is, for every element y belonging to y, there exists an element in x such that fx is equal to y. The function f3 and f4 in figure 3rd and 4th are onto function. f1 in figure 1 is not onto, as element e and f in x2 are not the images of any element x1 under f1. Now most important thing, a function f from x to y is onto if and only if range of f is equal to y. Now we will define bijective function. A function f from x to y is said to be 1, 1 and onto or bijective if f is both 1, 1 and onto. Working rule for proving a function to be 1, 1. Assume for some x1, x2 in domain, if fx1 equal to fx2 implies x1 equal to x2, then f is 1, 1, otherwise f is many 1. Working rule for proving a function onto. Take any arbitrary element y from codomain. Now check if it has a pre-image in the domain. Then take y equal to fx. Then find the value of x. If x lies in the domain, then f is onto, otherwise f is into function. Now let's solve some question based on the definition we just studied. First question is, show that the function f from r star to r star defined by fx equal to 1 by x is 1 1 and on 2, where r star is the set of all non-zero real numbers. Is the result true? If the domain r star is replaced by n with codomain being same as r star. Let us assume x1, x2 belong to r star such that fx1 is equal to fx2. Now applying the definition of function, we'll have 1 upon x1 is equal to 1 upon x2. We are applying the definition of the function, and the function was fx is equal to 1 by x. Now cross multiplying will get x2 is equal to x1. So this is the definition of 1 1 function. It implies f is 1 1. Now remains the second part, that is ontoness. Let any y belonging to R star. Here R star means the codomain. Now if y belongs to R star means the set of non-zero real numbers, then 1 by y will also belong to R star because y is a non-zero real number, so its reciprocal will also be a real number. Now let us find f of 1 by y. F of 1 by y as per the definition will be 1 upon 1 by y, and it is equal to y. Hence it implies for every y belonging to y, it implies for every y belonging to the codomain, there exists 1 upon y belonging to R star. This is the domain, hence f is onto. What we have done here, we have taken any arbitrary element from the codomain and then we found the value of f1 upon y, and it found to be y. It means that every element, any arbitrary element of the codomain have its pre-image in the domain, hence it is onto. Now we have shown that the function f is 1 1 and onto, hence our result is true. Now comes the second part. In second part, it asks that if the domain R star is replaced by n with codomain being same as R star. Now we have to check whether this result is still true or not. Let us take one element 2 from the codomain. 2 belongs to R star. Now let us assume there exists an x belonging to the domain n such that fx is equal to 2. Now what is the definition of fx? 1 by x is equal to 2. Now keep in mind that x belongs to the domain and which is a set of natural numbers. Now let us find the value of x. X will be 1 by 2, which does not belong to the set of natural number. Hence, this implies when we replace the domain with r from r star to natural number in the domain, the function is now not onto. The function will be still 1 1, but it will not be onto now. Let us take the next example. Check the injectivity and surjectivity of the following function. First, f from n to n given by fx equal to x square. इंजेक्टिविटी का मतलब होता है 1 1, सर्जेक्टिविटी का मतलब होता है on 2. So let us check whether it's injective and surjective. Let us do the first part. Let us assume x1, x2 belonging to the domain n such that fx1 is equal to fx2. Now applying the definition of function, it is x square. Here it will be x1 squared, and this side it will be x2 squared. Now this implies x1 is equal to x2. Usually here it is plus minus x by 2, but as natural numbers are all positive, therefore there will be no plus minus sign here. This implies f is 1 1. That is, the function f is injective. Now let us check surjectivity of this function. The function is fx is equal to x square, domain and codomain being n. Now let us take a number, say 2, from the codomain such that fx is equal to 2 for some x belonging to the domain. Now applying the definition of function, we'll have x square is equal to 2. It implies x is equal to square root of 2. It may be obviously plus or minus, but as x belonging to the domain n, so it cannot be negative and irrational. This implies this x does not belong to the domain. Hence, we conclude that f is not onto. F is not onto. Now let us come to the second part. Let x1, x2 belonging to the domain Z such that fx1 is equal to fx2. Now applying the definition, x1 square is equal to x2 square. It means x1 is equal to plus or minus x2. It means that x1 may be equal to minus of x2. That is, x1 and x2 are not always equal. Hence, it implies f is not 1 1. For example, here minus 2 and plus 2 will have the same image 4 in the codomain. Hence, the function from z to z given by fx equal to x square is not 1 1. Now let us check whether the function is onto. The definition of the function was f from z to z such that fx is equal to x square. Now let us assume, let for say 2 belonging to the codomain, there exists fx is equal to 2. So from the definition of the function, we'll have x square equal to 2. As x belonging to the z in the domain, z is a set of all integers. So there is no integer such that its square is equal to 2. There is no such integer whose square is 2. So hence f is not onto. ये onto भी नहीं है. Now let us solve the third part. Here we have f from R to R given by fx equal to x square again, but domain and range are now changed. Now let us assume, let for some x1, x2 belonging to R, this R is for the domain, such that fx1 is equal to fx2. Now applying the definition of the function, we'll have x1 squared is equal to x2 squared. It implies x1 is equal to x2 or x1 is equal to minus x2. It means that x1 is not always equal to x2. It means f is not 1 1. It will be 1 1 only when x1 is equal to x2. Here we may get x1 equal to minus of x2. Hence, in this case, f is not 1 1. That is injective. Now let us check whether this function is onto or not. Let minus 2 belonging to the R, that is the codomain, such that minus 2 is equal to fx, or minus 2 is equal to x square as per the definition of the function. Now we know that there is no real number whose square is negative number. So it means that x does not belongs to R. That is the domain. This implies f is not onto, because minus 2 does not have any pre-image in the domain. Because minus 2 does not have any pre-image in the domain. Hence in this case f is neither 1 1 nor onto. Now let us solve the fourth part. Let us assume x1 comma x2 belonging to n. This let x1 comma x2 belonging to n the domain, such that fx1 is equal to fx2. This implies, applying the definition, x1 cube is equal to x2 cubed. Now transposing to the same side, we'll get x1 cube minus x2 cubed is equal to 0. Factorizing will get x1 minus x2 is equal, we'll get x1 minus x2, x1 square plus x1 x2 plus x2 square is equal to 0. This will give you x1 equal to x2 as the second part give rise to imaginary number. So hence f is 1 1. Now let us check whether f is onto or not. Now let us take 2 belonging to such a natural number in the codomain, such that 2 is equal to fx. This implies 2 is equal to x cubed. This implies x is equal to cube root of 2. But cube root of 2 is an irrational number. It does not belong to the set of natural number which is in the domain. Hence, f is not onto. Now let us check the function f z to z given by fx is equal to x cube for 1 1 and ontoness. For 1 1ness, let us assume for some x1 comma x2 belonging to the z in the domain, such that fx1 is equal to fx2. This implies x1 cube is equal to x2 cubed. This implies x1 cubed minus x2 cubed is equal to 0. This also implies x1 minus x2, x1 square plus x1 x2 plus x2 square is equal to 0. This implies x1 is equal to x2 as the second part gives no real numbers. As the second part gives no real values, hence we conclude that if fx1 equal to fx2 implies x1 equal to x2, hence f is 1 1. Now let us check whether f is onto. Let y is equal to 3 belonging to the codomain z, such that fx is equal to 3. This implies x cube is equal to 3. This implies x is equal to cube root of 3. But cube root of 3 is an irrational number. Irrational number does not belong to the set of integers. Hence, f is not on 2. Hence, f is not on 2. So that's now. In the next lesson, we'll learn about the composition of two functions. Thank you.